We are going to study the derivatives of inverse trigonometric functions in lesson 64 today. We'll go ahead and find what these derivatives are to start with, and then we'll do some examples, and then we'll see integrals that when we integrate, we will get the inverse trig functions. So let's go ahead and jump in. We don't know what the derivative of arc sine of x over a is yet, so we're going to find that. So what we need to do first, so we can have it in a more familiar form, is we're going to take the sine of both sides. And when we take the sine of both sides, we get sine of y equals, these two cancel, equals x over a. And we can differentiate that. This is going to be cosine y dy equals 1 over a dx. And we can find dy dx. So dy dx is 1 over a, and just show what we're doing here, we'll multiply by 1 over cosine y, and we divided both sides by dx. So we get dy over dx equals 1 over a times 1 over cosine of y. Well, we have now the derivative of dy dx in terms of y, and we don't really want that. And so what we're going to do is we're going to take this idea right here, that the sine of y is x over a. That means there's an angle, so we'll name this angle in our triangle here y, whose opposite side is x, and the adjacent side is, the hypotenuse is a. Well, now that we have this said angle, angle y, maybe we can find the cosine of y and plug that in. Well, cosine is adjacent over hypotenuse. Well, we don't have the adjacent side, but we can find it using the Pythagorean theorem. So let's call this m. So we would have x squared plus m squared equals a squared with the Pythagorean theorem. Subtract x squared from both sides, and then take the square root. Plus or minus square root of a squared minus x squared, and so that's our value of m. And its length, so we can just do the square root of a squared minus x squared. Now we can state what this is. So we have 1 over a times 1 over the cosine of y. Well, the cosine of y is adjacent, square root of a squared minus x squared over a. And we can simplify this. We can think this, we'll just multiply both top and bottom by the reciprocal of the bottom. That will cancel for us. There's different ways to simplify that, so this is just one of them. So a cancels with a, this cancels. We are now left with dy dx equals 1 over a times, really what we're left is this, and those a's will end up canceling. So really this tells us dy dx is 1 over the square root of a squared minus x squared. So that is one of our derivatives. That's the derivative of arc sine. We'll get back to that later. We're just going to find a couple other ones here. Well, let's find the derivative of arc cosine. Now that we've done one, this is going to be very similar in technique. We don't know this derivative yet, so we can't just state what dy dx is, so we're going to take the cosine of both sides. So we have cosine y equals these cancel equals x over a. Now, we can kind of look ahead and realize we'll probably need another side in the triangle here, so we can use the fact that cosine of y, some angle y, is x over a. Well, this time this is the adjacent, and this is the hypotenuse. So we have x and a, and this might be some side m. So x squared plus m squared equals a squared. We can subtract x squared. And once again, we get m equals the square root of a squared minus x squared. Well, now, hold on to that for a minute. We'll go ahead and differentiate here. So this is the differential of sine of y is negative, sorry, cosine of y is negative sine y. dy equals 1 over a dx. We'll go ahead and let's just actually write this in now. It might be a little easier. So negative sine, well, sine of y, so this right here, sine of y will equal opposite, which was the m, or the square root of a squared minus x squared. So this is the square root of a squared minus x squared. That was opposite over hypotenuse. dy equals 1 over a dx. And now we can multiply both sides by the reciprocal. At the same time, we can divide both sides by dx. So we'll divide by dx. We will multiply both sides by the reciprocal. So that's negative a over the square root of a squared minus x squared. So over here, this all cancels, and we have dy dx is equal to, the a's simplify again, negative 1 over the square root of a squared minus x squared. And there is our derivative of inverse cosine. Now realize here x is, these come from these values up here when you find those derivatives. We can keep going. We can do inverse tangent. We can do inverse secant, inverse cosecant, inverse cotangent. They're all going to be similar. So now what we have tangent or inverse tangent. So let's take a look at this. We don't know the derivative of inverse tangent yet, so we're going to take the tangent of both sides. And we are left with tangent of y equals x over a. But this time, x and a don't involve the hypotenuse. They actually have to do with the opposite and the adjacent. So our opposite, so here's angle y, opposite is x, adjacent is a. The hypotenuse is going to be, let's just call h for now, h squared equals a squared plus x squared. Take the square root of both sides, and we have h equals the square root of a squared plus x squared. Now we're going to differentiate. The differential of tangent is secant squared. So secant squared y dy equals 1 over a dx. Well, secant is, by definition, secant of y is hypotenuse over opposite. So we want the hypotenuse. So hypotenuse is the square root of a squared plus x squared over opposite. I'm sorry, over adjacent. I think I said that incorrectly before. Opposite over adjacent. Sorry, hypotenuse over adjacent. So this is over a. But it's secant squared, so this whole thing is squared. dy equals 1 over a dx. So when we square this, this squared in the numerator cancels with the square root, so we just have a squared plus x squared. In the denominator, we have a squared dy equals 1 over a dx. And now we can solve for dy dx. Divide both sides by dx. The same step, we can multiply both sides by the reciprocal, which is a squared over a squared plus x squared. A squared over a squared plus x squared. So these cancel, the a squareds cancel, and the derivative of inverse tangent is 1a cancels with one of these, the dx's cancel, and we have a over a squared plus x squared. And so that's the derivative of inverse tangent. We will look at one more because it's a little bit different. So we have arc cosecant of x over a. X over a has to be greater than 0. Find dy dx. So once again, we don't know the derivative of arc cosecant, so we're going to take the cosecant of both sides. So we have cosecant y equals x over a. We're going to differentiate soon. We're probably going to need to know the 3 sides of the triangle, so we'll go ahead and do this. Cosecant, remember, is hypotenuse over opposite. Hypotenuse over opposite, so x is the hypotenuse, and a is the opposite. Solving for m, m squared plus a squared equals x squared. So m squared equals x squared minus a squared. Take the square root, and m equals the square root of x squared minus a squared, which we will use at a later time. All right, now we want to differentiate cosecant. Well, the differential of cosecant is negative cosecant y cotangent y dy equals 1 over a dx. All right, I'm going to just do this a little bit differently. So let's see if we have some room to do this. Instead of working with cosecant and cotangent and plugging in now, I know that I can multiply both sides by the reciprocal of cosecant, which is sine. In fact, I'll do negative sine to cancel with the cosecant, and I can multiply by tangent to cancel with that. So we're going to multiply both sides by negative sine y tangent y. And at the same time, we can both go ahead and divide by dx. And so we have dy dx equals 1 over a. And now we're going to plug back in. Actually, we'll put the negative out front here because of the negative. Sine is opposite over hypotenuse, so that's a over x. And then tangent is opposite over adjacent, so that's a over adjacent, which was this m value, so the square root of x squared minus a squared. We have some canceling that happens, so dy dx is equal to negative a over x times the square root of x squared minus a squared. So we've gone through most of them. We could go through secant, but it's really a lot like arc cosecant. So we don't often find the derivative of arc cosine, arc secant, arc cosecant, or arc cotangent. So instead of memorizing them all, we could figure those out like we just did, but these are the 2 that you should memorize. These 2 should be memorized. So the derivative of inverse sine or arc sine and the derivative of inverse tangent. Now notice here there's a u here. instead of the 1 or the x, because that could actually be a function, and we would have to use the chain rule. So let's take a look. So inverse tangent, y equals inverse tangent of cosine of x. What's dy dx? I know you don't have these memorized yet, but there they are. So we can find dy dx is going to be a, which is the denominator. So we're kind of using this formula now. So a, which is the denominator, which is 1. So we have 1 over u squared. Well, u squared was cosine squared. That's what the function was. So cosine squared x plus a squared, which is 1. So we can think of this over 1 if that helps you with your u and a. So plus 1 squared. And then we have to take the derivative of what's inside. We've got to do the chain rule. So the derivative of cosine is negative sine of x. And so our answer, dy dx, equals negative sine x over cosine squared x plus 1. It almost looks like a Pythagorean identity, but it's not, so we will just leave it like that. Let's try this one. So we have arc sine of 2x, and we want to find the derivative of that. So y prime will equal, and now we'll be using this one over here. It's going to equal 1 over, and again we can say this is over 1. So we have the square root of a squared, which is the denominator. So 1 squared plus, sorry, not plus, minus. So minus u squared, well that's our function, so minus 2x squared. But then we have to take the derivative of what's in the function, so times the derivative of 2x, which is 2. So we have y prime equals 2 over the square root of 1 minus 4x squared. And then the last thing we want to do is look at some integrals here. Now, integrals in the past, if we had a fraction with some variables in the fraction and addition or subtraction, we would sometimes, like maybe there was a square root, so we could relate it to a square root and change it to a negative 1/2 power. Or sometimes, like this one, we might first think it looks like maybe it's natural log, except with the problem here, the derivative of what's in the denominator is not in the numerator. So it's not natural log either. So we're going to have to recognize some of these that wouldn't first be like, oh, that looks like a trig function, but it is. So notice this is a 1 squared plus an x squared. Well, that looks a lot like that, and 1 on top. And so this looks like our tangent. So if the derivative of inverse tangent was a over u squared plus a squared, the integral of a over a squared plus u squared is going to be inverse tangent. So this is going to be inverse tangent of x over 1, x over a, which plus c, which obviously is just, we don't have to put the over 1 there. And so we want to be able to recognize those as inverse trig functions. And that is it for